Okay, so we have already discussed the critical path method or CPM through this channel, and I have already explained that project network analysis through Pert and CPM is of two types. There are two types of project network. One is the deterministic project network, and another is the probabilistic project network. And the deterministic network is that one for which everything is predefined. That is, the durations are given, the relationships are all given. And we have already calculated the critical path and given you some examples of critical path. Now we will be dealing with the other kind of project network, that is called Pert, which is a probabilistic network, as PERT is the process through which we we calculate the critical path of a probabilistic project network. And PERT is, full form of PERT is project or program evaluation and review technique. The basic difference in this case is this is more realistic. Pert problems, because the project the durations are for different activities, the durations are generally varies, although we estimate some values of the duration, but that always may not satisfy. So what we can do, we can take a problem like this and do it elaborately. Let's take a problem first, then we will do the project network. Let us take an example to explain the Pert network, PERT, that is program evaluation and review technique. As I have already said, that it's a probabilistic model, which means that the activity time for a particular activity is not fixed, and that is what happens in real life. Although maybe we are doing the similar things, same things time and again, but due to some other circumstances, due to some environmental difficulties, we may get different time, or we may need different time to complete the similar kind of activities. So in reality, although we could do the same work, but it requires different time for completion of that particular activity in different days. So similarly, here is a Pert network where the activities are given A, B, C, D, E, F, G, H, I, J, K, and the predecessors are given. Now for each activity there are 3 different times are given in days. So these 3 times are called TO, TM and TP. Now TO is actually defined as optimistic time. So optimistic time, how TO or optimistic time is defined. The optimistic time is the minimum time required to complete that particular activity. Or in other words, we can say when we are doing that particular activity, when everything goes smoothly, no hamperment, no barricade, no difficulties come across during the activity, then everything goes smoothly for that particular activity, and we can complete that particular activity within a particular period of time. So less than that particular time, the activity cannot be completed. So optimistic time for an activity is the minimum time required to complete that activity. So for activity A, TO, that is optimistic time, is 2 days. Then there is another terminology that is called TM, or most likely time. Most likely time. How we define the TM or most likely time? The most likely time is defined as the time required to complete the activity in general. And we expect when we do that a particular activity, we expect that activity will be completed within that particular stipulated time. when there will be certain difficulties, some difficulties that we may come across during the activity of that particular job. So in general, whatever that particular activity takes time, that is defined as the most likely time. And thirdly, there is so for activity A, TM, that most likely time is 4 days. And finally, TP is called the pessimistic time. So pessimistic time. So how we define pessimistic time for an activity is the maximum time required to complete that particular activity. Or in other words, we say that when everything goes haywire, when everything goes wrong, when we do that particular activity, if everything goes wrong, some certain difficulties come across during that activity, so get delayed, and the process ultimately is finished within a longer period of time, and the maximum amount of time that could be stipulated to complete that particular activity is denoted by TP, or pessimistic time. So that means for activity A, the TP or pessimistic time is 6 days. For activity B is some values are given. So for each activity, as you can see, for each activity A, B, C, D, E, F, G, H, I, J, K, L, there are 3 different times are given for each activity. So which implies that to do that activity in real life, the time may vary to complete that particular activity during the process. So which is more realistic way of explaining that, and that's why, because of the variance of time, the variation comes, and hence the probability. If it is prefixed, then there is no probability, no variance, no chance of delay, or no chance of getting diversified, getting change of time in that particular during that particular activity. It could be there, but in real life, although we sometimes think about a particular activity could be completed that period of time, but it may not happen when you do that actually. So in that case, for each activity, in case of part, the probabilistic model, there will be 3 different times will be given, and using those 3 different times, we have to calculate an expected time to complete that activity. So we denote that T small e, it's expected time for an activity, and it is defined as T is defined as TO plus 4TM plus TP by 6. It simply is a weighted average among the 3 different values that is being given. How it has been derived, it is because it is defined this way, and if we take the probability for different activities, it comes generally this particular kind of weightage is suitable. And T is defined as the expected time. It's a weighted average. So where say if we are doing the same thing again and again in 6 days of a week, if we are doing going to a college, and generally we take some particular time, and some days, a few days we take lesser time to do those job, and some few days we take greater time than that expected time. But most of the days we take similar time to complete that particular job. So we put higher weightage in case of TM, and also because there is variation, we define the variation of each activity as variance for each activity. This is defined as the variance for each activity is calculated as TP minus TO by 6 whole square. This is how the variance of each activity is calculated. And as we have done in case of CPM, critical path method, using the values of TE, we calculate the critical path, and by that we find the expected duration of the project. Now, as you can see, I have written the question like, draw the project network, calculate the expected completion time of each activity. So expected completion time of each activity is denoted by TE. Also calculate the variance of each activity, that is what we have denoted by sigma square, and then find out the critical path, expected project duration and standard deviation of the project. And finally, as this is a probabilistic model, we will be finding out the expected duration of the project, not the exact duration of the project, because we expect that the project will be completed within that particular time. As there is a variation of days, it may not be completed within that particular period of time, and that's why this is the probabilistic model, and we will be trying to calculate the probability of completion of the project up to certain days. So how that can be done, we will be discussing that a little later. Let's first try to draw the graph and calculate the basic things, then we'll draw the graph. So as we have done earlier, so from the predecessor we will be calculating the successor, and as I've said, you may not calculate the successor, it is not necessary. If you can draw it correctly, that's well and good. So A's to recapitulate just, so A's successors are B comma C. I'll find where it appears. So B's successor is D, C successors are E comma F, E successor is D successor is G, E successor is also G, F successor is H comma I, H successor is J, sorry, G successor is J, H successor is also J, I successor is K, J does not have any successor and K does not have any successor. So from this table, what are the information that we gather is here only starting activities A and end activities are J and K. So let's try to draw the graph first. So we'll start with the node, and then this is your A, because a single activity will be there at the beginning. From A, then B and C starts. So write B, C. So I just mark A, B, C I have drawn. Then from B there is a D, from C there E and F. So D, E, F, then G is from D and E. So combining D and E will get G. Then from F we will get H and I. Okay, like this H and this is I. So G, H, I, and G and H. Combining G and H we get J, and from I we get K. So that is our graph. So let's put the node numbers there. So put the node numbers there. 1, 2, 3, 4. If you remember, that number in the arrowhead must be greater than the number in the arrow tail. So there will be 4, this will be 5, this will be 6, this will be 7, 8, and finally this is 9. So that completes the graph. So after we have drawn the network, let's calculate the small t and sigma square. So small t is the, as I have defined, expected time for an activity, and sigma square is the variance of each activity. So let's calculate that. Okay, so T formula is TO plus 4TM plus TP by 6. That means you have to multiply the most likely value 4 times, and then you have to add TO and TP and divide by 6. So first one, it becomes 4. 4 4s are 16. 16 plus 2, 18 plus 6 is 24, divided by 6 becomes 4. So 3, 3, 3, if you add and divide, you will get 3. This is 4 into 10, 40. 40 plus 10 is 50. 50 plus 4 is 54. If you divide by 6, that becomes 9. Then 10, 10, 16 is 40 plus 10, 50, 50. 50 plus 16 is 66. So if you divide by 6, it becomes 11. Then 15 into 4 is 60, 72. 72 plus 24 is 96. So if you divide by 6, it will become 16. So this is 9. This will become 10. This is 5. 20 into 4 is 80, plus 5 is 20. 80 plus 5 is 85. 85 plus 23. 85 plus 20 is 105 plus 3, 108. So if you are dividing by 6, it will be 18. So then next one is for I is 8, 9 and 10. It becomes 9, 13 and 31. Okay, 4 into 13 is 52. 52 plus 13 is 65. 65 plus 31 is 96. So if you divide by 6, it will become 16. Then this one is 7.5 into 4 is 30, plus 7, 37. 37 plus 17 is 54. So if you divide by 6, it will become 9. So that gives you the values of T, so expected duration of each activity. Then sigma square. For sigma square, you will use this formula, TP minus TO by 6 whole square. And for betterment, we will keep the values in fraction, because that will help. And in case of T also, if in some cases, if the value is coming as point or some fractional values, it's better to keep that in fraction, to keep that in the value under 6 in the denominator. If you keep it 6, that will be easier, because everywhere the values will be in that kind of similar kind of fractions. So that will be easier to calculate. Do not put a decimal place, because if you are dividing by 6, this will be a recurring decimal will be obtained. So it's not, and if it is not divisible, then it will become a recurring decimal. So it's better. And approximation, as far as less approximation could be done, that is good. Now sigma square. For sigma square, it's TP minus TO by 6 whole square. So 6 minus 2 is 4. 4 by 6 is 4 by 6 is 2 by 3. If you square it, that becomes 4 by 9. 3 minus 3 is 0. 10 minus 4 is 6. 6 by 6 is 1. So square is 1. 16 minus 10 is again 6. 6 by 6 is 1. 1 square is 1. 24 minus 12 is 12. 12 by 6 is 2. 2 square is 4. So 9. This is a 0. 12 minus 8 is 4. 4 by 6 is 2 by 3. If you square it, it will become 4 by 9. 2 by 3 square is 4 by 9. 23 minus 5, I think it's 18. 23 minus 5 is 18. 18 by 6 is 3. 3 square is 9. 10 minus 8 is 2. 2 by 6 is 1/3. So if you square it, it becomes 1 by 9. 31 minus 13 is also, I think, 18. 31 minus 13 is 18. 18 by 6 is 3. 3 square is 9. And 17 minus 7 is 10. 10 by 6 is 5 by 3. If you square, that will become 25 by 9. So that gives you the sigma square values. So we have already done the graph. We have already obtained the t or expected duration. And what we do, we will do similarly what we have done in case of CPM, that we will calculate the earliest start and finish, latest start and finish, and do the find the critical path with the duration, expected duration, and then we do proceed further. So if we let's write it here. So activity, then we'll write expected duration, that is small t, right? Expected duration of each activity. So here expected duration is each activity. Then we'll write the earliest and start, finish, then latest start. I hope you remember. If you do not remember, just refer to the previous videos that I have posted. And then finally the total float, exactly similar that the way we have done in case of CPM. So I hope you remember what is total float, free float, and independent float we have already defined earlier. So we'll just calculate the similar way. And activities are A, so I'll write B, C, D, E, F, G, H, I, J, and K is my final activity. And if you remember that, yes, now I will put the nodes in place. So A is 1 to 2, because that will help me calculating my earliest and latest time. B is 2 to 3. B is 2 to 3. C is 2 to 4. D is 3 to 5. E is 4 to 5. F is 4 to 6. I'm referring to the figure, I'm referring to the picture over there, figure, the network that I have already drawn. So I'm just writing the notes. F is 4 to 6. Here G is 5 to 7. G is 5 to 7. H is 6 to 7. I is 6 to 8. J is 7 to 9. And K is 8 to 9. Oh, one thing I forgot, that I should have checked the predecessor from the figure. I should have checked the predecessor and successor. So let's go back and check. So A does not have predecessor, successors are B and C. So A does not have predecessor, successors are B and C. B's predecessor is A, successor is D. That's fine. C's predecessor is A, successors are E and F. C's predecessor is A, successors are E and F. D's predecessor is B, successor is G. D's predecessor is B, successor is G. E's predecessor is C, successor is also G. E's predecessor is E, successor is G. F's predecessor is C, successors are H and I. So F predecessor is C, successors H and I, P, F, G. G's predecessors are D and E, successor is J. G's predecessors D and E, successor is J, fine. H predecessor is F, successor is J. H predecessor is F, successor is J, fine. I's predecessor is F, successor is K. I's predecessor is F, successor is K. J's predecessors are G and H and do not have any successor. J's predecessors G and H and no successor. And finally K's predecessor is I and no successor. K's predecessor is I and no successor. So that is okay. I should have checked it earlier, but no problem. Now, so here now I'll write the expected duration. So we have already calculated T, so I'll just place the T column over here. So A's T value is 4, B's value is 3, C is 9, D is 11, E is 16, F is again 9, G is 10, G is 10, then H is 18, I is 9, J is 16, and then finally this is also 9. So if you remember, we have calculated the earliest and latest. So anything that is starting from the node 1 starts from time calculation starts from 0 value, so 0, and finishes 0 plus 4 is 4. So those same formulas for your reference, we again write that EST is earliest start time is plus TIJ is EFT. EFT is your early finish time is early start time plus TIJ, and latest start time is latest finish time minus TIJ. So these two are the important formulae, and also total float. If you remember, we will calculate start minus start, LST minus EST, or LFT minus EFT. So start minus start or finish minus finish, we have said that we will check both to make that sure that the calculation is right. Okay, so we are doing that. So earliest finish time at 2 is 4. So whatever starts at the node 2, their beginning time is 4 units. So 4 both. So when I go to 2, then I'll at the node number 2, then I'll see where I have got to reach node number 2. So that particular value is 4. As I've said in the previous video, that this column corresponds to my start column, and this particular node column corresponds to my finish column. So anything that starts at node 2, time starts at 4 units. So 4 plus 3 is 7, and 4 plus 9 is 13. So 3. So next input is at 3. So 3, to put it here, what value should I put? I go back, I refer back where I have found 3. So that's the corresponding value is here 7. This becomes 7. 7 plus 11 is 18. 4. Again, where I have found 4, I'll go refer. So this is 13. This is 13, and next one is also 4. So this is also 13. 13 plus 16 is 29, and 13 plus 9 is 22. 5. Right. So 5, where I have found 5. So I have got 2 places where I have found 5. So one is 18, the other is 29. So if you remember that I have said, when we are moving in the forward path, that is what we are moving in the forward direction. We have to take the maximum value at a particular node. So that means this is 29 should be there. So 29 plus 10 is 39. Then 6, again I refer where I have got 6. 6 is 22. 22 plus 18 is 40. So 7, at 7 there are again, okay, 6, sorry 6, there is another note 6, here 6 is 22, 22 plus 9 is 31, 7, so where did I get 7, two values 39 and 40, I have to take maximum, that is 40, so 40 plus 16 is 56. 56, and here 8, where did I get 8? 8 is, to refer 8 as at 31, so 31 plus 9 is 40. Now as you can see, here again the node 9 has two values, 56 and 40, so that means there are several paths to reach at 9. So if you are reaching via J, then it takes 56 days to complete, and if you are reaching via K, then it is taking 40 days to complete. But what I can say at the end, that at 9 all the values, all the activities will be completed, can be completed not before 56 days. So latest finish time at 9 must be 56 and not 40. Although I have got two values at 9, but latest finish time at 9 is 56, not 40. So for this we will be putting 56.